So our final speaker for this session, the panel will be half an hour break after this, and then the panel will start at 5. But our final speaker is Chris Murray. Chris has held several senior positions in National Grid. He was Director of National Operations there, amongst other senior roles. But he's now Chief Executive Officer to ExoServe, one of the gas subsidiaries of National Grid. Chris.
Okay, thanks very much, Frank. One of the beauties of coming to an academic institution is you get educated. And I'm very grateful to Yanis for actually educating me, because I've been working in an engineering business for many, many years now, and I've been confused by my engineers on a daily basis. And I now realise that as somebody who actually by academic training is an economist, if I stop applying P and Q as price and quantity, it might actually solve all those myths and they'll drift away. Anyway, thank you for the invitation to be with you this afternoon. I'm particularly pleased to be here because I was invited by the mathematics KTN. One of my other hats is I'm the chairman of the Energy Generation and Supply KTN. So I think it's fabulous that the KTNs are not just working within their own spheres, but reaching out and working together. And certainly from the discussions so far this afternoon, everything that I've seen amongst the discussions, whether they be from the mathematics, the engineering, or the energy perspective, are really just fascinating. I thought I'd start with a very brief discussion of, or illustration of who we are, because National Grid is actually both a gas and electricity delivery business. We're an international business, 50% UK, 50% US. The US bit is usually a bit of a surprise to people. In fact, we have probably about twice as many people in the US as we have here in the UK. We are the second largest energy provider in the US. We supply gas and electricity to about 8 million consumers in New England and New York. And here at home, of course, we are very much at the heart of the UK's energy systems. We own about 140,000 kilometres of gas distribution and transmission mains, and through our distribution business we supply about 11 million customers with gas. We also own the high voltage electricity network in England and Wales, and we operate the whole of the network both onshore and increasingly offshore going forward. Now this infrastructure is being and will continue to be upgraded, but now we have this fantastic opportunity to move to a smarter, more interconnected network, and that will require substantial investment. A number of colleagues have spoken about that today, and some of you might have heard the announcement last week that having spent £14 billion over the last 5 years on investing in our networks, we plan to spend £22 billion over the course of the forthcoming 5 years. Why? Well, because there is no question that our world is changing, and the roles of the utilities will be important in the transition to the low carbon economy, and the model of these large connected sources of energy, whether they be gas or electricity, are changing as we move to this brave new smart enabled world where we see much more by way of distributed systems, and we as National Grid expect that our role will change as we become a key enabler to that transition. And of course we all know the reason for this. Principal driver being climate change, no longer a topic for debate in terms of whether it's a reality or not, but certainly fierce debate in terms of the solutions that are required going forward. Electricity generation, of course, accounts for about 32-ish% of our CO2 emissions. That, of course, is not the whole picture. Transport and heat play significant roles. I'm not going to debate those today. I'm sure they will have been debated during the course of this week, either to date or through the remainder of the week. So they can't be ignored. But actually looking at the electricity situation is something where there will be a big difference going forward. This is probably a slightly different way of looking at some of the things that Steve showed us, but hopefully very consistent. This plant margin that we were talking about earlier, that's the buffer of plant above peak demand that we like as this very conservative system operator that we've been described as a couple of times. We like that traditionally to be something in excess of 20%. And if I go back 3 jobs, when I was the system operator or responsible for system operation, then something north of 20% would leave me feeling not very nervous, which is good. As we move forward, unless something else happens, and things are happening of course, we'll see a very rapid deterioration in the plant margin, largely caused by this, the impact of the Large Combustion Plant Directive and the more polluting coal and oil stations coming off the bars, but also nuclear starting to come off, the ageing fleet, and indeed some of the early CCGTs coming off as well. Now, here's the point, not too distant into the future where you start to get into negative margins. Do I get worried at that point? Well, no, I don't. I start getting worried about here, way back here, which of course is me being a very conservative system operator. I used to be, of course. And here in the UK, we do have incredible reliability in terms of security of supply, and it's something that we've got used to. I was musing earlier with colleagues about the fact that when I lived on the northeast coast of Northern Ireland, when the wind blew hard, the lights went out. Usually only for 15, 20 minutes, but we were used to it. We were already paying the highest electricity prices in the UK, and the question was, do you want to pay more for your electricity, or do you want to actually just know where the candles are from time to time? And we generally said, it's fine, we know where the candles are. So I said things are happening. Large amount of new CCGTs to be built. This is at the margin, of course. Significant renewables, most of it wind, and as Steve said, you have to derate that because of the intermittency thing. Clean coal starting to come into play. I'll come back to that shortly. Clean coal, very important technology for us going forward. And the start of the new nuclear sets coming on. So we don't see this desperate drop-off in plant margin because of actually things that are in train and anticipated going into the future. Recently, however, what we've been seeing is that the only significant build that's been going on is in gas, and gas represents about 40% of the current installed capacity. The other big chunk here is coal, and we get other renewables, wind, existing nuclear stations, which of course are in need of retrofit and replacement, and then some interconnectors around the margin. If we move to 2020, then the big difference here is even more gas stations being built. A number of reasons for that. Firstly, as Steve mentioned, you can build them very quickly, so if you've got worries about capacity, you can get them built. They are, of course, polluting. As somebody who has spent most of his life in the gas industry, we used to say, you know, natural gas is the least polluting fossil fuel. But we used to use that word polluting, and of course, with our concerns over climate change in more recent years, that probably isn't a phrase I would have been using had I known. Some declining coal here, start of CCS technologies coming in. The big difference, of course, being wind coming onto the network and some other renewables. Slightly declined nuclear here before we start to see the new stations coming on, and again at the margin, a little bit of interconnector. And then by 2030...
That's peak, by the way, is it?
This is a peak, yeah. By 2030, gas starting to decline, more and more CCS coming on, again continuing a very significant role for wind and other renewables coming on. Nuclear starting to expand as the new stations start to open up, and indeed interconnection at the margin. Now, I've said at the margin, and the reason I've said at the margin is because in this modelling we're being quite conservative, and we're assuming that at peak demand what you get is actually interconnectors, or the assumption we make is that interconnectors are floating. And that's a very simple assumption, but it's only half of the story. And in a world where there is more polarisation between time variable generation or less flexible generation than there is today, then actually interconnectors do play a key role in terms of security of supply. And we do see a significant increase in the amount of interconnection going on at the moment. We have a couple of interconnectors in place, 500 megawatts here across to Northern Ireland. There's a 2 gigawatt link owned and operated by ourselves. and RTE already in place, and then 2 under development. Another link here to Ireland. BritNed interconnector, 1 gigawatt interconnector being developed between ourselves and Tenet, the Dutch system operator. So those are the ones that are in place and under construction. 3 others being considered, another interconnector to France, 1 to Belgium, and indeed 1 up to Norway. So lots and lots of potential for new investment in interconnectors as well. But of course, interconnectors are not the only things that are happening offshore around our island. The wind resources that we have around UK waters are absolutely vast. And as you saw from those charts earlier, we do expect to see wind playing a very significant role for our energy picture here in the UK. But the reality is that progress has been slow. It's about 10 years now since the Crown Estate announced the first round of UK offshore wind development sites, and it's 7 years since the second round. And in that time, we've only seen some 390 megawatts of generation to connect. But it is pleasing to see that we've got 8.8 gigawatts actually contracted to connect in the future. In our offshore development information statement, which we published in December, we shared a number of potential scenarios for offshore wind, ranging between 10 gigawatts in 2020 to 33.5 gigawatts in 2020. Now that's a massive range, and one of the key variables, of course, will be the developments that we see in both energy policy and the regulatory environment. Are we going to get the right incentives and policies in place to actually facilitate these products coming to market? And our Gone Green scenario, and I know it fits in very well with some of Ofgem's scenarios as well, so it sits between the two. And in the Energy Network Strategy Group report published last year, jointly published by DEC, Department for Energy and Climate Change, and Ofgem, there was a scenario that looked at around 16.5 gigawatts of offshore wind. And if you put that together with other onshore renewables and other renewable generation, you can actually get to the point where you do meet the 2020 emissions targets for the UK. But that scenario represents a near doubling of the applications that we've got to the system at the moment, and more than 40 times the offshore installed capacity right now. So there's an awful lot to do. So what are the implications then for market, the operators, the investors? Well, the NSG report envisaged a fair amount of onshore wind in Scotland, but also the capacity for some tidal and some offshore coming down. In the east coast here, both on and offshore wind, and of course nuclear stations starting to develop. And then the southwest and Wales, again on and offshore wind with potential nuclear stations. And since that report, of course, we've had the announcement of the nuclear sites and indeed the national policy statements. That drives £4.7 billion worth of potential investment onshore. If you add to that the investments in smart grids, the offshore wind, interconnectors, all that, you can see that there's an awful lot of investment required between now and 2020. And then you add something that Yanis reminded us of, which is the need to replace the existing grids. You can see that some of the numbers that Steve were talking about absolutely are in the ballpark, depending on the scenarios that you're looking at. So if we've looked at the generation picture, and we recognise that gas plays a very big part in generation, because at the moment we're looking at about 40% of our electricity coming from gas, and it'll probably go somewhere closer to 50%. Let's look at a potential gas world, and we can see that the picture has been changing rapidly and will continue to change rapidly. So this is UKCS gas, our indigenous gas supplies coming off the North Sea. If you go back not very far, about a decade, we were pretty well self-sufficient. 100% roughly of our gas coming off the North Sea, and we've seen it start to go into decline, and by the end of the next decade, possibly even slightly earlier, we'll see about 20% of our gas coming off UKCS, so 80% reliance on imports. What's bridging the gap? Well, a fair amount of Norwegian gas coming in already. LNG starting to play a bigger role in the UK, other continental gas supplies coming in. And as we go forward, you can see that the big change is, of course, in LNG. So we've gone to a point where we are very much linked to global markets going forward. And just as Steve remarked, you can look at this in two ways. You can say, actually, here we were very self-sufficient. We didn't have to worry about security of supply because we had our own indigenous natural gas. You could also say, well, all our eggs were in the same basket. If we had some major failures at, say the likes of Fergus, that we were in real trouble. And over here you could say, actually, this represents significant diversity of supply because LNG, for example, can be coming in at numerous points around the network. So, what does this mean, and what has it meant last few years? Well, significant investment on the gas network, numerous new connections, particularly over the winter of 05-06, a lot of new capacity came on. New Langlead pipeline came in, Bacton Balzand interconnector. More recently, we've just spent £1 billion building a pipeline from Milford Haven to connect the two new LNG terminals there to actually connect into the national transmission system. National Grid's own LNG facility down here at the Isle of Grain started off with phase 1, expanded it to phase 2. This year we commissioned phase 3, we're now talking about phase 4. Other LNG starting to come in elsewhere around the country, and new Norwegian supplies coming in as well. So an awful lot of investment has been taking place in recent years, and going forward we'll expect to see even more. So what does this then mean, this potential gas world of, say, 2020, where we might see 80% of our gas being imported and we might have 50% of our electricity generation coming from gas? I think the key issue is, can we supply the needs of UK PLC? Well, if we think demand's around this sort of level, then going forward, if you put together declined but still important UKCS gas, Norwegian supplies, LNG supplies, continental supplies, and the potential for new storage, you could certainly envisage a world in which capacity far exceeds demand. Of course, the reality is, having the capacity doesn't mean that you actually get the molecules flowing your way. So it is really about whether the market signals are such that we get gas flowing into the UK, whether it's through interconnectors or whether it's from our continental supplies, or indeed it's from LNG that is operating on a global basis. What does this mean then in terms of future investment? Well, I've talked already about some of the investments that have taken place over the last few years, but if you want a fully flexible gas system where you can cope with any mix of gas supplies, wherever they're coming from, so Grain, Teesside, Milford Haven, wherever, then you might need around, say, £3 billion worth of additional investment to provide the flexibility on the system to deal with those various supply scenarios. Then add on to that the demand side, so additional CCGTs being built, and wherever they're going to be located on the network, investments so that we can actually get the ramp rates so they can deliver electricity generation onto the bars. And while I'm touching on the issue of gas, let me just touch again on this very important issue of carbon capture and storage. If you look at, say, a Scottish network and a Teesside network, then they've got the capacity to capture significant amounts of carbon equivalent to pretty well taking all of the UK's cars off the roads. So extremely significant technology for us going forward. So lots of investment opportunities and challenges for National Grid, but there are of course the additional operational challenges for us going forward. How would I sum these up? Well, actually it's a bit simpler on the gas side than the electricity side. On the gas side, it's about moving from where we are today, so the major flows coming in from UKCS and Norway, to a position where much more diversity coming our way, but particularly lots of LNG flowing into the country, LNG that is, of course, linked to global markets. Steve gave the example of the winter of 2005, when price signals in the UK in pure markets would have brought gas in, but because of activities of people at the other end of pipes, for example, gas wasn't actually allowed to flow in. Similarly, we could think about hurricanes Katrina and Rita, where gas LNG ships that were ostensibly on their way to the UK just kept steaming west over to the US. I think that's actually a bit of a myth, but it's a nice story in terms of you can get events that happen around the world, and then with LNG, you have the capacity for LNG to respond to that. And when you think that the cost of operating a terminal is only about 9% of the total LNG supply chain, if you've got full supply chain players, then actually they can move their ships around and decide where they're going to put them without actually damaging the economics of their terminal too much. For me, though, the far more fascinating situation is in electricity. Think about it today. We walk into our homes, our businesses, our offices, and we consume electricity. We turn a tap, we flick a switch, we turn our plasma TVs, we use our PCs, all that sort of stuff. And what happens is that demand is a given. And the market, with National Grid acting in a residual capacity, provides a balance on a second-by-second basis, and we try and make sure that the frequency doesn't drop too far away from 50 hertz. And it works extremely well. Really works extremely well. In the future, where we will have much more intermittent and perhaps less flexible generation, I suspect that what's going to happen is that generation will turn up, and then we will flex our demand in order to respond to that generation. And in order for that to happen, we will need things like smart meters, we will need things like smart grids. Hopefully we'll move to a situation where we do have large-scale battery storage, because that, from an operator's perspective, would be extremely valuable, and indeed in terms of smoothing prices would be really important. So quite a different electricity future, one that I think is 180 degrees opposite to the one that we live in today. So, as you can see, we do have some substantial challenges and opportunities ahead, and of course the future can only be delivered by people. And jobs in the energy industry are really at the heart of the UK's economy going forward. So it's a real shame then that actually engineering isn't perceived as something that is a great career option by our education system. And forgive me, but I couldn't resist the opportunity whilst I'm here at Cambridge to just share with you the output from some research we did into attitudes towards engineering. So we asked several hundred 16 to 19-year-olds, their teachers and their parents, what they thought about engineering. And in response to the question, how would you describe engineering, we heard menial at times, overalls not suits, fixing and mending things, unsociable hours, physically demanding, low paid. Do you get that, Steve? Low paid. Low paid, a job not a profession, men not women. Now, in fairness, I have to say, I have 27,000 people, well, there are 27,000 people in our business. There's an awful lot of engineers, and I don't think too many of them would say that they are low paid. It's very sad that the vast majority of these people that we spoke to actually couldn't even name a single recent engineering achievement. And I suspect, my phone's not there, I suspect most of them have got mobile phones. And when you think, or I think what I can do with my phone today, probably the only thing it can't do for me is eat and drink. But other than that, it does pretty well everything. And we heard a parent referring to their son who wanted to be an engineer, and they said, although I would support him, I know he could do better. and I probably would be disappointed. And actually, even more scarily, a careers teacher said, an engineer, that's like a high-end builder, isn't it? Well, if the people who are advising people on potential careers don't actually know what engineers do, I think we're struggling. But if we are going to transition to this low carbon economy, then we've all got to work together, whether it's government, industry, academia, to change this perception of engineering. And we've all got to work together to make sure that engineering, science and mathematics are valued as a career going forward. So we have an awful lot to do. Energy is a very, very busy landscape. And as I said in my opening remarks, I think National Grid is very much at the heart of that. I do trust that, today my sort of thoughts and insights have given you just some idea of the challenges and opportunities that we face in National Grid today. Of course, it's very difficult to predict the future. You can only predict so far in. But as Alan Kay said back in 1971, the best way to predict the future is to invent it. And I do think that we and the people that we work with do have the capacity to invent the future. We know the challenges, we know the constraints, we know the opportunities. And I think that actually all of us here today have actually got to get on and invent just a bit faster than we are at the moment. Because if we don't, then the probability of us meeting these very challenging emissions targets that we've got is diminished going forward. And I don't think that's something that any of us should be prepared to counsel as we try to deliver a more sustainable and secure energy future for the UK. Thank you very much.
Time for a quick question or two, so there's one from there.
In terms of, I'm John Brooke from the University of Manchester, in terms of trying to predict future demand, how much can you look at coupling between gas supply and electricity supply? Because clearly they can be used for certain the same things, heating is a classic example, but there's others. So is there a possibility that coupling those two systems might give us the stability?
Yeah, I mean, as far as I'm concerned, there's no such thing as a gas issue or an electricity issue these days. If you've got a gas issue, you've got an electricity issue, and sort of vice versa. One of the things I mentioned very briefly is the issue of heat and how actually we need to address that going forward, and actually decarbonising homes and moving more and more gas out of homes going forward and replacing that with renewable heat, of course, which will take renewable electricity rather, which will take a long time. So yes, I think you can do a lot of coupling. There's a fair amount of studies going on at the moment in terms of actually what the future needs will be on both the gas transmission and distribution network, as opposed to the distribution and transmission networks for electricity. And it really depends on actually which of the scenarios that you back. And of course, the problem with scenario planning, or certainly the problem I perceive with scenario planning, is you do an awful lot of work on it. And then you say, we think this is our most likely scenario going forward. So you start to plan towards that. But then you still have to remember to have that sort of cone of uncertainty around that scenario, because you may get deflected off by a variety of other things, not the least of which could be an emerging technology. I certainly feel, as a personal belief, that in order to meet some of the 2050 targets, we're going to have to see some emerging technologies that we just don't know about at the moment. Thank you.
So David?
Okay. Just a factual question about, you showed these three bars of the way that scenarios for the way that energy production would be made up. I think it was electricity. I could understand the sort of distribution within those bars, but I was puzzled because I thought that if we're going to decarbonise, that means taking more oil out from off the road or whatever, and therefore we have to generate more electricity. And your final bar for 2030 actually was shorter than your bar for 2020. Do you understand?
Yeah, I do. I do.
So
I do.
Deconfuse me.
I will try and deconfuse you, but in order to do so, I will need to deconfuse myself first. So I'll look back at the slide and I'll deal with it in the panel in a moment.
Okay, good.
Because certainly we do see that going forward, you can see more and more demand for electricity with the things like EVs.
Yeah.
But also you can see the impact of people becoming more conscious of their energy.
Energy efficiency in the home and stuff.
Correct. And actually using less energy. So there's an awful lot of energy wasted today. So you have to take that into account at the moment. There's two ways of solving the problem. One, of course, is to decarbonise. The other thing is to use less energy.
Right, so I'm sure that will come up in the discussion. So two quick questions, first from Mark and then from David, and then we'll stop.
Yeah, for the last 10 years, I'm not from the UK, I'm an Irishman, but for the last 10 years I've heard, and although I don't live here, every month I hear an announcement from the UK about targets for renewable. And yet they're continually making targets, and you must get sick of them. But yet, yet. You don't seem to be getting very far. And it's interesting. Well, no, but I mean, you are having problems rolling out all these renewables. But yet in the gas network, you've been able to develop it very quickly. So there's a difference between developing gas infrastructure and electricity infrastructure. I mean, it seems to be easier to develop gas infrastructure, isn't it? I mean, you put up a map there and you said, we've made all these investments in gas, you built them. I don't think you've got an equivalent map for electricity because you've struggled to get planning permission, et cetera, et cetera, et cetera. So there's a difference. And how are you going to make yourself as efficient at developing the gas network, electricity network? Because if you don't, you'll never make any of these targets.
Yeah, I mean, I think it's a great point. Just a few points. Of course, a lot of the investment that's taken place to bring additional gas into the UK has been offshore in terms of new interconnectors, new fields coming in, or expansion of existing facilities like our UK, like the Isle of Grain, or new facilities like Milford Haven. Now, for Milford Haven, we had to build £1 billion pipeline connecting Milford Haven ports to the NTS, the National Transmission System. And there were very, very difficult and long protracted planning and consent issues around that. And in fact, actually for one of the compressor stations, we are still trying to get consent and planning permission for that one. So it's actually operating at slightly less than full capacity because we're trying to get that built. I think going forward, something that is of great concern to us is actually where the planning regime is going to end up. Because with the IPC, we believed we'd got a single body that would be time-bound in terms of the time taken to actually deliver decisions on things like electricity infrastructure. So if you're hooking up the new nuclear stations, for example, getting some certainty around those. New coalition government, of course, has said that it doesn't want the IPC. I believe it's going to sort of meld its workings into the planning inspectorate, but the decision will still be with the Secretary of State. Now, whether the Secretary of State is going to be bound by the sort of timeframes that we envisage on the IPC or not, I don't know. I did say there's an awful lot to do. There is an awful lot to do. Sorting out planning and consent regime is critically important because otherwise we will get behind the curve. And I think it was Yanis showed some demonstrations of some of the lead times to do with getting these things built. And if I tell you that the last very, very, very big piece of electricity infrastructure we built was the Second Yorkshire Line, well, as I recall, it was a couple of years to build it, but I think it was 10 or 11 years to get consent.
Right.
Well, in that sort of world, we don't get the sort of connections that we need. So we need everything to fall into place, the planning regimes, the regulatory regimes, and the commercial regimes.
David? Final
Mark
question.
was arguing this morning that we need to have a centrally planned system, the old CEGB, in which you simultaneously optimise transmission and location of generation. So have you done the scenarios in which if you had the control over where to put the wind, you would work out the least cost combination of the two, and would it then still be in the top left-hand corner instead of the bottom right-hand corner, with or without constraints on whether you can actually build lines? Because the pessimism about whether you can build anything anywhere, I think, is pretty large, but maybe we can overcome that. So there are two possible scenarios: you can or you can't, and then you decide where to build. And then the follow-up question is, does your system of pricing access to the grid for wind under command and control and all the connect and manage and all of those things allow you to actually steer those investments where you want them to be?
Okay. I think there's really two questions with two parts to it, and probably several different answers we could give. The first part about actually, do you plan in a central way and trying to optimise in terms of price? Historically, certainly for the last couple of decades, we've been responding to market signals. So whether it's market signals of where new gas wants to come onto the network or indeed new electricity wants to come onto the network. Because we've got to actually get on with a lot of the large-scale investments now in order to facilitate things like renewables coming down from Scotland, the ENSG report recommended that certain strategic or anticipatory investments, as we're now calling them, could go ahead, and Ofgem has been progressively allowing money into the operators' price control so that we can actually get on with some of this stuff, sort of a build and they will come in a sense, but trying to do so in the best informed way to make sure that actually those investments are still seen or still deemed ultimately to be economic and efficient, and we do have a duty to be economic and efficient. The second point about the pricing signals on the grid are that we have to meet two obligations. One is actually to promote competition, and the second one is to be economic and efficient. And I know there's a lot of debate, for example, in Scotland in terms of whether the grid charges are sufficient to actually attract all the generation on, but then one also has to take into account that where that generation is up in the northeast is an awful long way from the demand centres, and you have to put an awful lot of investment in order to get the energy from A to B. So if government or others decide that they want us to move to a different model, and there's been several consultations on it so far, then actually we're pretty agnostic in terms of how the model works. But at the moment, of course, we have to make sure that we are really reflecting our licence obligations, and at the moment we do get sort of cost-reflective pricing. So if you're a long way away and a lot of the generation is from the demand centres, then it's going to cost a fair bit. Similarly, though, of course, it means you get well rewarded for generation.
Right. An afternoon like this takes a lot of organising, so I think I should mention those that have put the effort into organising it. So we should thank Stan Zachary, Chris Dent, Robert Leese, Richard Gibbons, Sergei Foss, John Leeson, and Ben Mestel for doing the organisation. And Steve Greenham has been recording it, so if you want to watch these presentations, look at the presentations, watch video of the speakers, then that will be available on the Newton Institute website in a week or two. And so finally, can I just ask us to thank the speakers for their the quality of their presentations and the skill with which they delivered them. So thank you all very much.